Now I will show you how to use our circuit breaker analyzer to test the circuit breaker. If this is the first time you're using our circuit breaker analyzer to test the circuit breaker, please be aware that the main difference between our circuit breaker analyzer with other brands is that we have already integrated a DC power supply inside the circuit breaker analyzer. The output voltage could be 30 volt to 265 volts. That means if you test the circuit breaker on site, you should switch off DC power supply to circuit breaker before you conduct the test with our circuit breaker analyzer. Now I will show you how to use our circuit breaker analyzer to test the closing test of the circuit breaker. This is the main menu. We select CB close. Here is the reference connection diagram. So we make connection first. Please be aware that you should connect the grounding for circuit breaker analyzer first before you make any other connections. So we connect the grounding for circuit breaker first, and then we connect the contacts cable for circuit breaker analyzer and the circuit breaker. We use global 1, A1, B1, C1 to test the circuit breaker. Now another side, A1, B1, A, B, C, we connect to phase A, phase B, phase C of the circuit breaker. And another side of the contacts we shoot together. Then connect the short contacts to grounding. Here we connect to the same grounding point of the circuit breaker analyzer. The second cable you should connect is the sensor cable. Here we connected a 25mm near reach sensor. This is already installed on this circuit breaker, so we connect it to the driver port. The third cable you should connect is the control cable. The closing and opening control cable should be connecting to the closing coil and the triple off coil of the circuit breaker director. You can find the connection point from the system diagram of the circuit breaker. For example, for this circuit breaker, now is at the opening state. Now the ignition is opening. That means if you have connecting corrector, when you test the continuity between the closing coil, you should get a low winding resistance, for example 10 ohms or 7 ohms. It should not be open. Now after you finish the connection, we come back to the test the setting setup window. Here we select internal power. That means the control power generated by our circuit breaker analyzer. Here input the rated voltage. The rated voltage could be found from the name plate of the circuit breaker. For our circuit breaker is 220 volt. Second is the sensor selection. Now we have installed 25mm near reach sensor, so we select the 25 near reach sensor. The standard configuration including a rotated angle sensor, a 250mm near reach sensor, and a 25 near reach sensor. For distribution circuit breaker, we suggest that you can use a 25mm near reach sensor. For transmission circuit breaker, you should use a 250mm near reach sensor. For bus distribution and transmission circuit breaker, you can use a rotated sensor. The sensor selection for rotated or near reach sensor depends on the installation. If rotated sensor is easy for installation, you can use a rotated phase angle sensor for testing. If near reach sensor is easy for installation, you can use a near reach sensor for the testing. Here the driver setting. There's one more thing, that the bonding port of the testing means the valency the velocity and the currents will be calculated according to A1. If you are using A1 for the velocity calculation, if you are connecting the circuit breaker with the analyzer in globe 2, means A to B to C2, you can change the bounding point to be A2 or B towards C2. The context model. If you select the context as time mode, that means the testing just measure the operation time only. But if you select the contact mode as closing resistance, for example, for some high voltage transmission circuit breaker, there is a pre-incision resistor installed on the circuit breaker. At this model, the circuit breaker analyzer will measure the pre-incision time of this resistor, and also analyzer will measure the resistance value for the pre-incision resistor. And here, circuit breaker information, station ID and circuit breaker ID. This will be part of the saved file name. Here, reference break profile. This means if you already know the brand and the manufacturing of the circuit breaker for testing, and also the standard requirements of this circuit breaker already been imported to the database of the circuit breaker analyzer, you can just select the manufacturing and the reference break model. Then analyzer will compare the test results with the standard requirements. If all the test results comply with the standard requirements, analyzer will give you the test result pass. If one or some of the test items does not comply with the standard requirements, analyzer will give you a test result failure, and also analyzer will list the failing items of test result. Here is induction of the contact states. For example, now we have connecting A1, B1, C1, and the break is at open state. So A1, B1, C1 should be open. The induction is open. And here, A1, B1, C1 shows O, means open. If this is the first time you use our circuit breaker analyzer for testing on site, please check the system setup window. The most important parameters at the system setup window is that test time, that including the path length of closing, path length of opening, and the test time. Test time 400 milliseconds means the analyzer will stamp 400 milliseconds in total for the whole closing tester. And the configuration of delay time should be 0. The second you should be check is that the velocity bounding point. Here the selection could include all the 12 channel time measurement port. This port selected will be used to calculate the velocity and the control, the testing control for CO tester or OC tester. And here is the velocity definition. For velocity definition, because this value does not listed on the IEC standard, so the velocity definition normally is given by the manufacturer of circuit breaker. Some manufacturing using 10 milliseconds or 5 milliseconds before closing or after opening. But some manufacturing may be using 10 millimeter or 5 millimeter before closing or after trip off. Or any other definition you can use it define. And here preset storage time. This normally used for isolated switch GAN. That means if the test time already exceed the maximum 4,000 milliseconds, you can use preset storage time to extend the test time. That means, for example, if the isolated switch GAN operation time is maybe 10 seconds, then you can set in here at 7,000 milliseconds, means 7 seconds, and here at 4,000 milliseconds. That will be enable the total test time to be 7 seconds to 11 seconds. And here is normally for test report earning. So this window, you can just kill at the first time when you using our analyzer to conduct test. Now everything is ready. We conduct a closing test. Now if we click run, then okay, here is the test result for data. The data including closing time for A1B1C1, bounce number for A1B1C1, bounce time for A1B1C1, and here is the closing velocity or closing speed, average velocity or average speed. The average speed defined by the average speed from command enabled to circuit break contacted. This is the speed definition or velocity definition. Stroke means the total travel. Currents means the gap between the contacts. The over travel. Maximum current means the maximum peak current flow in the closing coil during closing test. Here we check the cover. If you select the cover's view, here we can see the orange cover is the current cover during closing test. The white cover is the travel, and this red circle is the closing point. From here to here means the currents. From here to here means over travel. From here to here means the total travel or stroke. And the yellow, green, red cover is the contact states. The blue cover is the velocity cover. If you want to compare the test result with saved cover or standard cover, you can use a compare. For example, we use a compare. You select another test result for comparison. For example, we select the closing. We can see this is the compare. The white one is the test we just done. The red one is the test we get last time.